All right, guys, part 2 of the video, starting out with number 9. So the end behavior, we're going to start with that end behavior here of this graph. All right, so we got to look at the two ends. So what point is this headed towards? Well, this graph is headed left and up. So the x-coordinate that this graph is headed towards is negative infinity. The y-coordinate, because it's going up, will be positive infinity here. Okay, so that's coordinate point here. As a limit statement, here's how we write that. The limit as x approaches the x-coordinate, which is negative infinity, of our function is equal to the y-coordinate, which is positive infinity. Remember, this is just a coordinate point here, x comma y. But this direction, the end behavior, is approaching the coordinate point positive infinity, negative infinity, is heading right and down. So here, I'm going to just copy and paste that limit statement. But we're going to change a couple of things here. So what we're going to do is we're going to get rid of the negative right there, but move it to right here. Right, because now x is positive infinity, y is negative infinity. So that's what that says right there. Now at D, what is the multiplicity? Well, this crosses, so it's probably 1, right? But we know for sure that it has to be odd, whether it's 1 or 3 or 5 or whatever, right? But so the multiplicity of x equals D must be odd for number 9 here. Number 10, we're looking for the equation of our function. And so to start with the leading coefficient, we always look at to the right. This graph is headed down to the right, so we're going to put a negative in front of this function right here. It might also have a number attached to it, but we don't know what that number is, so I'm just going to put negative number out front. Now, there's 3 zeros here, so that leads to 3 factors that we can go ahead and write out. So x minus 1 gives us x plus 1. X equals 2 gives us x minus 2. And that would give us x minus 4 right there. Now the exponents, right? At -1, the graph bounces. And if it bounces, it's got to have an even multiplicity. So it might be a 2. Right here, it might be a 4. I'm going to put a 2, but anything even would be fine there. At x minus 2, it crosses. So it's got to have an odd multiplicity. Now, it sort of goes sideways, and so it's probably not to the first. I'm going to put to the third, but again, anything that's odd would be acceptable right here. And then at 4, the graph crosses. Again, it's going to have an odd multiplicity, so it's going to be something like to the first or the third or the fifth, something like that. All right, number 11 says f of x is an even function, and then we're given a coordinate point. I went ahead and plotted that coordinate point, and we're told that that point is a relative maximum. So the graph close by, we don't know the rest of the graph yet, but close by the graph looks like this. It's a relative maximum. We have no idea again what the rest of the graph is doing. But for an even function, it's going to have y-axis symmetry. So let's go ahead and reflect that point. If we reflect it, it would be right here, and the rest of the graph would go with it. So that is also a relative maximum right there. Okay, so this right here is also a relative max. And its y-coordinate would be the same. Right, so the x-coordinate for an even function, the x-coordinate changes signs, the y-coordinate does not. That is because, even though this is our answer, just a little bit of background. So that is because f of negative x equals f of x. Right, so this says the x-coordinate changes signs, but the y-coordinates, the f's, do not. X-coordinates change signs, y's do not. Now, if this was an odd function, if from the beginning it said, hey, f of x is odd, well, it's not y-axis symmetry, it's origin symmetry then. So what would change is the x and the y would change signs. So right there. All right, so moving on to the next question. Last question here. We're looking for the number of distinct zeros of this function here. And so just to walk through this step by step, This 2 does not produce a 0 because there's no x. If it had an x after it, that would produce a 0. Right, so we're not going to do anything with that 2. But here, we've got an x plus 4 that gives us x equals negative 4. It has a multiplicity of 2, but that's 1, 0, not 2. Over here, we have x minus 2 times itself, which is just x minus 2 squared. So same thing. This is x equals 2 with a multiplicity of 2, but we only count the actual zeros one time. So this function would have 2 distinct zeros. All right, that's it, guys. Best of luck on your test tomorrow and stay flawless.